Hi, everybody, and welcome to this episode of Magnificent Math with Mrs. Murray. Bum, ba-da-bum. Today, we are going to be focusing on multiplying and dividing radicals. So in order to multiply radicals, what you're going to do is multiply the coefficients and then multiply the radicands. And the only thing you have to remember is that you can only multiply radicals if they have the same index. So, looking at our first example, we've got one term here, negative 2 root 11c, multiplied by this binomial here. So we have to distribute this negative 2, 11c in through to this term and this term. So in order to do that, what we're going to do is multiply negative 2 by 4 to get negative 8, 11c by 2c cubed to get 22c to the power of 4, and then negative 2 multiplied by negative 3 to give us positive 6, and our radicand would be 3 multiplied by 11c to give us 33c. From there, you're just going to simplify like we did yesterday. So this 22, we can't do anything with that, but c4, the perfect square of that is c squared. So we remove the perfect square of that, or the square root, sorry, of that to get c squared. This cannot be simplified further, so our final answer is negative 8c squared root 22 plus 6 root 33c. Second example, much like our first, this time we're working with cubed root, but the same laws apply. Multiply the coefficients or the constant terms, so 9 and 1 to get 9. Radicand is 2w and 4w to get 8w squared. Then we multiply 9 and 7 to get 63. 2w multiplied by 28 equals 56w. From there, we're going to simplify. So we have an 8 under the cubed root. The cubed root of 8 is 2. We move that to the outside, multiply it by 9 to get 18. We're left with w squared underneath the cubed root sign. Our second radical, we can simplify to 8 multiplied by 7w. Cubed root of 8 is 2. We move that to the outside, and we're left with 63 multiplied by 2, which equals 126. Simplified version of this is 18 cubed root w squared plus 126 cubed root 7w. Our last example is a situation where we have a binomial multiplied by a binomial. And if you think back to our previous learning, you should know that we are going to use FOIL in order to FOIL this out. So we'll multiply the first term by the inside term. We get 4 root 14. These two terms multiplied together equals 3 root 7. Then we have 3 multiplied by negative 5 root 14 to get negative 15 root 14. And our outside terms is going to be 4 multiplied by negative 5 to give us negative 20. 2 multiplied by 14 to give us root 28. Now we need to work on simplifying. So we're going to simplify our like terms. There's no, 4 root 14 can be combined with negative 15 root 14 to give us negative 11 root 14. Negative 20 root 28 can be rewrote as 4 multiplied by 7, because that will give us a perfect square factor here, which will simplify in the next step. And then 3 root 7 will just stay the same. So we're left with negative 11 root 14. When we simplify this further, we take the 2 to the outside, multiply it by the negative 20 to give us negative 40 root 7, and then we're left with 3 root 7. Simplify these two terms together, we're left with negative 11 root 14 and negative 37 root 7. Now, if we're dividing radicals with one term in the denominator, okay, what you have to keep in mind is when we're dividing radical expressions, you have to, you can't have a radical in the denominator, and we talked about this a little bit last chapter. And just like with multiplying, you're going to divide coefficients and then divide radicands. So what we have to do here is, these are not in simplest form, okay? We want to get rid of these radicals from the denominator. So I'm actually going to start with this example over here because it's the easiest. In order to get rid of the radical in the denominator, we want to rationalize this expression. To rationalize it, it means that we're going to multiply this by a rational expression that's equal to 1 involving this square root 6. So that expression is going to be root 6 over root 6. Okay, when we multiply these, the numerator, we're going to get 4 root 6 times 8. And in the denominator, it's going to be root 6 multiplied by 6, which is 36, and that simplifies to 6. Okay, and then further simplifying this, 4 root 6 multiplied by 8 is 48. Root 48 can be rewritten as 16 multiplied by 3. When we move that to the outside, we take the square root of 16 to give us 4. Multiplied by 4 will be 16 root 3. And then that further simplifies to 8 root 3 over 3. Moving on to our next example, here we have 3 root 3. When we go to rationalize this, we are only going to multiply this expression by the radical in this denominator. Okay, so just like we did over here, we're going to multiply it by the square root of 3 over square root of 3. We'll end up with 6 square root 51 times 3 over 3 multiplied by root 3 times root 3, which is just 3. And we end up with 6 square root 17 multiplied by 3, which is just 51 decomposed, to give us 3 and 3, because those 3's will move to the outside since it's under the square root sign. And when we move it to the outside, we get 18 over 9 root 17, and that can be simplified to 2 root 17. Okay, so again, simplifying these just like we did yesterday. Okay, this question becomes a little bit more tricky. The reason it's tricky is because we're working with a cubed root of 3, or the cubed root, okay? What we need to do in order to get rid of this is we need to think about what will make this cube root sign disappear is if we have 9p written 3 times underneath there, right? 9p multiplied by 9p multiplied by 9p. So what we're missing is 9p multiplied by 9p from under here. That is what we are going to multiply this equation by. Okay, we're going to multiply it by root 3, 9p over 9p, and the same thing in the denominator. When we do that, we're going to end up with negative 7 cubed root of 81p squared in the numerator. Our denominator, we're going to end up with 2, and then really what we would have if we multiply these two cubed roots together is 9p multiplied by 9p multiplied by 9p, okay? Or 9p cubed if you'd like. When we remove that, it just becomes 9p. So our denominator would be 2 multiplied by 9p. Simplifying, in the denominator we get 18p. In the numerator, we're going to break this 81p squared up to try and find a perfect cube. Okay, 81 is 27 multiplied by 3. 27 is the perfect cube, which we can remove. So we do that in the next step. So we have negative 7 multiplied by 3 cubed root 3p squared. So this 3 came from the 27 cubed. The cubed root of 27 is 3. And then simplifying that further, I've wrote this down wrong. Sorry, it should be negative 7 cubed, or sorry, negative 7, the cubed root of 3p squared over 6p. Okay, this 3 and the 18 can reduce. We divide this by 3, we divide this by 3, so we're simplifying it. So this here should actually be 6p. Okay. And the last thing that we need to know is when we divide a radical expression with 2 terms in the denominator, so we've got a term here of 3 root 5, and then another term of negative 4. Okay, what we have to do is we have to multiply that by the conjugate. So a conjugate basically is 2 binomial factors whose product is the difference of squares. So in other words, we have two binomials, we multiply them together, and their answer equals a difference of squares. In order to do that, what we're going to do is we're going to multiply the numerator and the denominator by the conjugate. So simply stated, the conjugate is the same terms, but with the opposite sign in between them. So we're going to multiply this by the same terms with the opposite sign in between them. Okay? So 2 multiplied by 3 root 5 is 6 root 5. Then 8 in the denominator, what we're going to have is, so in the denominator, it's going to simplify to 9 multiplied by 5 minus 16. And I'll just show you the work over here. So basically we've got in the denominator 3 root 5 minus 4 right over here. And we're going to multiply that by 3 root 5 plus 4. So again, we've got a situation where we need to FOIL. Multiply this first term by this first term. And it's going to end up being 9 multiplied by the square root of 25. Square root of 25 is 5. So we end up with 9 multiplied by 5. Then negative 4 multiplied by 3 root 5 would give us negative 12 root 5. And positive 4 multiplied by 3 root 5 would give us positive 12 root 5. Multiply negative 4 and positive 4 to get negative 16. So that's how we came up with the 9 multiplied by 5 minus 16 in the denominator. Okay, moving on, we're just going to simplify. So we get 6 root 5 plus 8 over 29. We can't simplify this any further. Okay, this is in simplest form. 8 and 29 cannot be reduced, nor can the 6 and 29. So that is the end of 5.2. Again, the new thing is to make sure that you know how to rationalize the denominator and understand this idea of conjugates. So good luck. We'll see you tomorrow.